This video, we're going to solve side-side angle triangles using the law of sines, though it's the ambiguous case, so we may end up with 0, 1, or 2 triangles given the situation, and we're going to have to figure that out as part of the problem. Give myself a little bit thinner pen here so that I can write a little bit more there. There we go. So we're given a side of 10 for A, a side of 5 for B, and an angle of 40 for A. It's very important that whatever angle they give you goes in the bottom left-hand corner of this triangle that you draw, and the side across from it goes right across from it. So 40 degrees goes down here, and 10 goes over here, and then the other side that they give you is going to go in this position here, meaning this is A and this is B and this has to be C in this triangle. So this is going to be little c is going to be the side that is unknown here, and angle B is going to be unknown. The first thing that we're going to try and do is see if there's any triangle at all using the law of sines. We're going to try and solve for angle B here. And so we're going to say that angle B, so sine of angle B is to side B as sine of angle A is to side A, and that sine of angle B equals 5 sine angle A over side A. So B needs to be arc sine of 5 sine of 40 degrees over 10. So arc sine of then 5 sine of 40 degrees over 10. And we get B is equal to 18.75. Okay. So yes, we have at least one triangle here, 18.75 and 180 minus 40 minus 18.75. It's going to give us 121.25. Now, the question is there another triangle that also works here? And there's a couple of different ways to figure this out. So there's a way in which we find the height of the triangle, which I'm going to do right now. That's just one of the ways that I like to draw it with drawing a picture. So I'm going to drop the height right here, and I'm going to say that the height is going to be equal to this side here, this hypotenuse, times the sine of that angle right there. And that's why you want it set up this way. So 5 sine of 40, this is 3.21. And so I can say that because the length here is bigger than the height, this side over here that we found is bigger than the height and bigger than this other side here, there's only going to be one triangle. Now let's go ahead and let's do the other method and see that it also tells us there's only one triangle. So there's one triangle where B is 18.75 degrees and C is 121.25 degrees. And little c we have to find here using the law of sines. So c is to sine of 121.25, degrees as 10 is to sine of 40 degrees. So C equals 10 sine of 121.25 degrees over sine of 40 degrees. Finish this up before we look at method 2. 121.25 divided by sine 40. All right, so 13.30. So everything to 2 decimal places there, according to the instructions. 13.30. Okay. Now, method 2, and I'm probably going to use this one a little bit more because this is what more of the teachers like to use, says that if there's a second triangle here, that we're going to have to find another angle here with the same sine value, meaning that it's going to be 180 degrees minus that angle measurement. So 180 degrees minus the 18.75 degrees. And I'm going to call that B prime is going to be 161.25. And we still have A was 40 degrees. And so if this 161.25 plus this 40 degrees is less than 180 degrees, which it is not here, then I can find angle C so that there's a second triangle. But we just proved to ourselves in a different way that there's no second triangle because this other angle that could be made that had the same sine value is too big to form a triangle with this 40-degree angle because the 3 angles altogether can only add to be 180 degrees. So there's only one triangle here. All right, let's look at this next example here. And we have angle B, oh my goodness, is big, is down here in this corner, is 130 degrees, and side B is right across from it is 10, and the other side C is given to us as 5. This is B, this is A, like this. And so we're going to first see if this actually makes a triangle. And so we're going to say that try and find angle C here, sine of angle C over side C equals sine of angle B over side B. So sine of C equals 5 sine of 130 over 10. C equals arc sine 5 sine of 130 over 10. It's the same as sine of 130 over 2. So arc sine of sine of 130 divided by 2. And that gives me angle C is 22.52 degrees. So I do have a triangle here. So add 130 to this and do 180 minus that. And that gives us 27.48 for angle A. And then we're going to find side A here to say that A is to sine of 27.48 degrees, and that's equal to 10 over sine of 130 degrees. So A equals 10 sine of 27.48 degrees over sine of 130 degrees. So 10 sine of 27.48 degrees divided by sine of 130 degrees. And this is going to be A is about 6.02. So that's my first triangle that now I'm going to see if there's a second triangle. So I'm going to say clearly there's not here because I already have my obtuse angle here. I can't get another obtuse angle, but I'm just going to show that to you, that this angle C that I solved for 180 minus 22.52 is too big for me to add to 130 degrees, and I'm well over 180 degrees. So there's one triangle here where angle C is 22.52 and angle A is 27.48 and side A is 6.02. Let's look at the next problem here, where we have angle A is 80 degrees and side A is 5 and side B is 6, and that makes this angle B and this angle C and this side C. So let's go ahead and solve for angle B. Sine of angle B is to side B as sine of angle A is to side A. So sine of angle B equals 6 sine of 80 degrees over 5. And angle B is going to be equal to the arc sine of 6 sine of 80 degrees over 5. Arc sine of 6 sine of 80 degrees divided by 5 is going to give me an error because it's bigger than 1 or smaller than -1, which tells me that there's no triangle that's produced. So that's let's just look at what that 6 sine of 80 divided by 5 is, and see it's bigger than 1. And so sine values have to stay between -1 and 1. Since it's bigger than 1, there is no angle that can give us a sine value of 1.181769304. So there's no triangle. Let's look at this next one. Angle B is down here in this corner is 10 degrees. Side B is 6. Side C is 7, is across from angle C. That makes this angle A and this side A. So we're going to solve for angle C. Sine of C is to 7 as sine of 10 degrees is to 6. So sine of C equals 7 sine of 10 over 6. Let's see what that 7 sine of 10 over 6 is before I get too far. Okay, that's within the values that I can take the arc sine of it. So let's do that and say that C equals 11.69 degrees. So That means that A equals 180 minus 11.69 minus 10, and that's going to be angle A. (158.31 degrees). 158.31 degrees, and this is 11.69 degrees. And let's find side A while we're at it now. The A is to sine of 158.31 degrees, as 6 is to sine of 10 degrees. So A equals 6 sine of 158.31 degrees over sine of 10 degrees is about 12.77. Now the question is there another angle that is going to be able to give me a second triangle? I think there might be in this case. We're going to see. So 180 minus 11.69. Then we're going to add that to the 10 that we were given, and that's less than 180 degrees. So yes, there are two triangles. So let me find the one with the smaller angle C. That's our first one. So C is 11.69 degrees, and angle A is 158.31 degrees, and side A is 12.77. Now for C2, we have 178.31, and that means that 180 minus this is 1.69. And so I'm going to try and draw that angle for that triangle for you. And this is be like so. This is still 10 degrees down here, but now this is 178.31, and this is 1.69 up here. And this side here is still 6. It's just coming down at a different angle. And this side here is still 7. And I want to find this side A here. So we use the law of sines for that. And we'll say that A is to sine of 1.69, as 6 is to sine of 10. So A equals 6 sine of 1.69 degrees over sine of 10. 6 sine of 1.69 divided by sine of 10. And that's going to be 1.02. There's one of our cases where we have two triangles. Just draw a triangle here now with the given angle of C is 110 degrees. Given the obtuse angle, I know that it's not possible for me to have two triangles, because the other angle that I'm going to find with 180 minus this acute angle is also going to be obtuse, and I can't have two obtuse angles. So I'm going for either one triangle or two triangles right now. This side is 3, and 0 or 1 is what I'm going for if I didn't say that. This is 7, this is A, C, this is B. I feel like this one's going to give me 0, but let's go ahead and see that I want to solve for angle A here. So sine of A is to A as sine of this is to this. So what's 7 sine of 110 over 3? Let's see if it's too big. That's what I thought. So because that's bigger than 1, there's going to be no triangle is produced here. So that side of 3 is not big enough to get down here and touch this base. Now let's look at this. I think this is our last problem here. So let's draw this triangle. The angle in the lower left-hand corner here is going to be 30 degrees. The side across from it is going to be 7. And the other side given to us is going to be 9. This is going to be angle A. This is C. This is B. So we're going to find angle A. So sine of A over side A is equal to sine of side C over side C. And so that's going to be sine of A equals 9 sine of 30 over 7. Let's see what this is. 9 sine of 30 divided by 7 is within our range, so that's good. Second arc sine, second answer is 40.01 degrees. So 180 minus 40.01 minus 30 gives us angle B is 109.99. Now we want to find side B to finish this up. So B is to sine of 109.99 as 7 is to sine of 30. Notice I'm always using the pair of given side and given angle as much as I can here. So B equals 7 sine of 109.99 over sine of 30. So 7 sine 109.99 divided by sine of 30. And I get 13.16. All right, let's see if there's a second triangle now. So that would mean A prime would be 180 minus the measure of angle A here of 40.01. I need to add that to my 30-degree angle that was given, and yes, that's less than 180 degrees. So this is still 30 degrees. This is 139.99 degrees. And so 180 minus that is 10.01 degrees. And let's see, C is still 7 and A is still 9. So we need to solve for B prime. So B prime is to sine of 10.01 as 7 is to sine of 30 degrees. So B prime equals 7 sine of 10.01 over sine of 30 degrees. 7 sine of 10.01 divided by sine of 30 is going to give me 2.43. So there's two triangles, and A1 is 40.01, B1 is 109.99, and little b1 is 13.16, A2 is 139.99, B2 is 10.01, and little b2 is 2.43. All right, that is going to be it for this video, and we'll come back next time and we'll talk about some applications of the law of sines. See you for the next video.